This lesson is going to be about Limelight. Before I start, I want to say the same thing that they say, which is try to keep your code as simple as possible. A lot of Limelight, a lot of camera vision, you can get really complicated, but in a lot of cases, you don't need it to be the most complicated thing. And so we want to make sure that we don't overcomplicate our code. So we need to analyze the game, analyze what we're using our vision for, and try to keep it as simple as possible. And also that way it's easier for people to understand. And for example, whenever we're teaching new students, we don't have to go through so many baby steps in order to have them understand the code. Um, but I don't have a robot, or I don't have a camera, and I don't have a Limelight in front of me right now, but I'm going to be using Microsoft Paint to kind of show a lot of it because it's not that hard. Um, I'm going to be using this square as an April tag, and then I'm going to be using, let's see, this will be my Limelight. So, and then this is how I'm going to be explaining this stuff. So, the first thing are these static methods. So these are like your basic methods. These are like kind of like the main things that you need to know. TV. So TV is literally, do you have a target in place? Can you see a target? So right now, TV would be 1 because the limelight, assuming that the limelight's vision goes out from here, and then it's in the field of view of the target, that means that the limelight's vision is 1. But for example, if there's a roadblock, if there's an obstacle here, or if there's something here and the limelight's vision is cut off, like this, then our TV is going to return 0. That's useful for, say, you're using pose estimation. You can't estimate your pose if you don't see a tag. So that's automatically going to get rejected, and that's it's just a very basic. TX and TY, I'm going to get rid of the limelight, and I'm going to instead put a crosshair. So if we look at the tag here, and then we look at where, assuming this is what we're looking at is the limelight's POV. So the crosshair is going to be here. Tx is the degree amount and angle from here to here. So if we draw a little line up here, and then if we look at it, actually it's easier if we look at it from top down. For Tx, if I'm looking at it from here, if we draw a line back here, you can see how we have this kind of triangle, right? So then here's the center of our tag, here's the angle to the actual thing. This value right here is going to be our TX. So you see how from the tag, so on here, this is the center, that this little line here, that value is going to be TX. And for some reason, they have it so that if your crosshairs to the right of the tag, so if this is to the left, then your TX is positive. So this angle is going to be a positive angle. But then if the crosshair is over here, this angle is going to be a negative angle. The next thing is TY. So TY is pretty similar. If this is our center and our crosshair is up here, TY is just, if we look at it from the side this time, TY is this angle right here. So right here. And so practically speaking, and then also this one above is negative, below is positive. Limelight has a weird frame of reference. But that's what you need to know about that. And then using these two methods, we can get pretty accurate auto align. So if it's over here, we use a PID controller and try to get our crosshair to be facing this. If we want to align for what is it called, lateral axis, and then say our things here, that means we're too far, or actually our line is always angled up. So if it's here, it's too far away. we need to move closer until it comes here, and then that'll help adjust our axial or our forwards backwards movement. And so using just TX and TY, you can get a pretty accurate auto align. The one issue with TX and TY is because it's angle based and it's not like distance based. If your robot's already at an angle, like say your robot, if this is the April tag, say your robot's faced like this, your limelight and your limelight's like this, your limelight might think it's straight on, right? But actually, you need your robot to turn first, and it needs to turn first, and then become square in order for it to be accurate. But a lot of the times, your driver is going to be pretty close to that angle, anyways. So a lot of the times, it doesn't really matter. Um, TXNC and TYNC, even I don't know what those are. They're probably very random. TA though is pretty useful. Like TY can be used to measure distance. TA is what percentage of the screen or what percentage of the camera field of view the tag is taking up. So then here, the TA would be pretty big, but if we zoom out, then this would be a very small TA. And so that's another way of getting like a rough distance estimate or how far away you are from the tag, which is what we used in 2024 because we didn't understand pose estimation nearly as much. Um, get T2D array. Um, Basically what that does is it sends an array with a bunch of information. Um, I don't think it would really be useful to us, but you can look into the docs and like learn more about that. Get target count is as it how many April tags it sees. Get raw fiducials is actually pretty helpful. I used that last year to do some like ambiguity stuff. So fiducials. So an April tag is called a fiducial. Basically, a fiducial is just a marker. It doesn't have to be an April tag. It can be kind of anything, but basically what it does is it marks. It is at a known location on the field, and it can be used to localize. Um, or not always, but it's meant like you can calculate your position relative to the fiducial. Um, and so getting that is pretty helpful because using the get raw fiducials, you can kind of do some more advanced pose estimation. You can do some more advanced math. Mechanical Advantage does it, but honestly, it's not going to come up very often. And now with our current with our current robot code, we don't use get raw fiducials for anything. So it's just another way to kind of filter your pose estimation because you can look for ambiguity, and basically what ambiguity is your camera is not going to be as pristine as Microsoft Paint. The way that they calculate poses looking at the corners, so it's going to look at these four corners and it's going to try to find the kind of transformation in space that it needs to do to undo any variations in the corners. So say your April tag looks something like this. It's going to look at the four corners, and then based on that, it's going to try to get it back to square. And then using that and like a bunch of math, it kind of figures out where it is on the field. And so if you're really far away, you can see how those corners kind of become blurry. Like even here, they're kind of blurry. And so if you have a really high ambiguity, what that means is that your limelight is very unsure about its actual position and it could be just giving you bad data. If you've ever looked at raw limelight data, you can see it jumps around. If you're far away, it jumps around a lot. That's that ambiguity. And so that's something to kind of consider. Um, get raw detections. I don't even know what that is. I don't think it's very useful. Pose estimation. Okay, so this is where it's kind of it's pretty important. Um, we're always gonna use either bot pose estimate WPI blue or WPI blue megatag 2 because before we code used to be written in regards to your alliance. So before we had Path Planner, before we had any of that, they used to write code and autonomous routines based on their field side. And so that way they could use the same autonomous for both sides. And like not have to change the code, but now it's so easy to change, and it's like Path Planner figures that kind of stuff out for you. So you always want to return stuff with the Blue Alliance because that is the new standard for pose estimation. Um, and then these these poses are not as helpful, like getting the bot pose 3D, because hopefully we're not ascending during our match in any way that we'd have to come back down. Um, it might be useful this season, but I'm assuming there's going to be no terrain, so we don't need to worry about that. These methods are pretty useful. Um, I'm not going to explain all of them, but the camera is the camera lens. You guys can kind of figure out the rest of it. The bot pose is the center of the robot. Target is the center of the April tag. Camera is the center of the lens. And so, or the center of the camera. I think it's the center of the lens. Yeah, it is. So based on that, you can kind of get a bunch of different transformations of how one of these relates to the other. Um, and so that way you can also do math with that. Like for pose estimation, you would use camera pose, or you could use bot pose, target space. That's what we did before because we didn't have the locations of the tags. And so that way you can kind of do everything relative to the April tag. So if you're ever doing stuff that's relative to April tags, not relative to your position on the field, for example, the reef, that wasn't really related to your position on the field. Um, it was more related to the position of the April tag, which you could store the April tag's position, but you don't need to do that. So these methods were useful for that. So if you're ever doing something where it's like not related to a physical location that's not related to an April tag in any way, and you're bot, if you're not in that situation, then you can probably use one of these and it'll be useful. Um, these are kind of the same thing except they flatten them so you don't get the it's or I guess instead of a pose 3D, they give it to you as a like an array. Uh, that's not going to be very useful. I mean, it might be a little bit useful for reasons that I won't get into, but it's I would rather this be used. Yes, I think I'd rather this be used than these. Um, Pipeline. Okay, now for the actual camera configuration. Once you're in the Limelight like hardware manager, these are kind of what you do there. We don't really use these methods, but they're good to know. So your pipeline index is, say you have, we don't use this, we only use one pipeline, but if you wanted to use the same camera for multiple things, like if our camera was mounted to like our intake on the 9128 robot, or is mounted to our bumpers on the intake side, we could have one pipeline for uh, pose estimation, but then we could switch to a different pipeline for like coral detection. Um, we don't have to worry about that. We will almost always use one limelight for one thing, so we only have one pipeline. Um, so that's not a big issue. Priority tag ID, basically, for example, this year, if you guys are doing FTC, um, the obelisk is not in a set location, and so because of that, like it's not in a reliable, precise location every time. And so because of that, the only two April tags you can trust are the April tags on the two goals. And so using the set priority tag ID, Um, or no, this is not what I think it is. Sorry. The priority tag ID is like, I guess it's the main tag that you're looking at. So what I was thinking of is something different. Sorry. I'll get into that after I explain this, but this is like the main tag you're looking at. I think what this does is it makes it so that you ignore all other tags. Um, so that's, I guess that would be useful if, for example, you were using an FTC and you only wanted to focus on blue goal or red goal. But uh, what I was talking about is in the Limelight Hardware Manager, you can set, let me see, in the Limelight Hardware Manager, you can set what what April tags. So if you go to the tracking April tag section and you go to ID filters, you can filter for which tags you want to look at. Which, for example, this year we could have only looked at the reef tags because those are the only ones that really matter. Everything else is relative to the reef in that game, and so we could have just filtered for the April tags that are seen that are on the reef, and so that's useful. That's very useful, especially in like, for example, this year's FTC game, as I was saying before, where only two April tags are reliable. Um, the rest of this is pretty useless except for set camera robot space. Again, we're not going to use this because we don't need to do it in the Limelight. We can do it in the web UI. But basically, what this does and what you will do whenever you configure Limelight is you ask the cadders or you measure it yourself if they don't have the CAD for some reason. You would measure the how forward it is relative to the center of the robot. So center floor of the robot. So center of the robot touching the floor. Based on that point, you see how forward it is. So you know which way is the front of your robot because you configure the swerve. You see how forward it is, how far to the side it is, and how far up it is, and also what angle it's at. And so that way, um, because otherwise your robot pose is going to be really off. It's going to be off by however forward it is, however to the like sideways it is, however high it is, and it's also going to be affected by the angle. And so this is a very crucial step in order to make sure that you have accurate pose estimation. You want to have as secure a limelight mount as possible, and you want it in a location that's known in CAD and also on the field, and those dimensions match up so that you don't have any issues with pose estimation and you don't have any like differences in what the in between what the limelight thinks is its pose relative to the robot and what the actual pose is. Um, some other things that you can do your with your limelight include crosshair calibration. So what this is kind of what we could do on last year on the what is it called? On the 2025 robot. We have two limelights, right? And so whenever we align to the reef, what we would do is we'd align to the reef. We get really accurate, really close and really accurate to where we wanted our robot to be, and then we click the calibrate XY. And what that does is, if you can see it in action here, the the camera the this crosshair moves to where the center of that object is, or for example, this is an old example, but wherever the center of the April tag is. And so that way, as I was talking about earlier, you can use that X and TY to align your robot without having to worry about a lot of the more complicated stuff. In order, I guess I should backtrack a little bit. In order to set up the April tags, literally just what we do is we do the quick start. Make sure that you have the everything configured correctly, because otherwise it's gonna look really weird and it's not gonna look the way it's supposed to. Um, and that's a no no. You can also it's good to set we're doing full 3D tracking. So a way, as I was talking about earlier, with setting the forward, back, and uh, like all of like this stuff, you want to look at the picture of the limelight, or like where the limelight is relative to the robot like that we have here, and you want to try to see, make sure that it looks as close to where you see it in real life as possible. uh like, just use your common sense. The dimensions in the cat are probably going to be accurate, but if it's like the opposite way from what you expect, just flip it around, and like, just make sure that it, just do an eye check, and like, if it looks like it's in the correct place, then it probably is. um Another thing you can check is the template that I have in the new code, or in the 2026 code base. It publishes the vision pose already. So what we can do is, in advantage scope, I don't, let me see if I can pull up the logs. But in advantage scope, you can you can see where every, where do all my settings go? Oh well. But in advantage scope, um you can see like where your robot is on the field. uh I'll send a example video in the group chat, I guess, because I don't know what happened to my advantage scope. But you can see your 2D pose on the field, and then using that, you can kind of see what's going on with that, and you can kind of you can see if it's accurate and if it's like facing the correct direction. Now I guess I'll talk a little bit about what we're going to be using. We're probably going to be using megatag. And so basically the code is already in there because advantage mechanical advantage is our go. But basically what we need to do is, we have a few things to update. We need to update these camera names. We don't need to worry, as they say here, we don't need to worry about the robot transformations because we can do that in the web UI. As I was talking about, max ambiguity. Ambiguity is how sure the robot is, the camera is, that hey, the tag is in the right spot, or I know where the tag is. Um, these ones are linear. So linear means translational. Angular is rotation. Um, these are called standard deviations. So if you guys have taken any statistics class, you know what a standard deviation is. Uh, to those who don't know, and to those who are kind of confused how this relates at all to FRC, basically, this is how much we trust the robot or the camera's position is going to be accurate rel- relative to its actual position on the field. So, for example, in this code, they have a standard deviation of 0.02 meters, which is about 0.75 inches. And so, what this means is that whenever they plop the robot down and they put it 1 meter, or about 3 feet away from, say, one of the tags on the reef, they can reasonably assume that their robot is going to be within 0.75 inches, or 2 centimeters, of the actual place where the robot should be. Um, and so there are a lot of ways you can tune this. Um, One of the best ways is to take out a ruler, measure, meter, and then do a bunch of tests. Um, that is something that I don't know if I I think that is something that we should look into, but we can also set the linear standard deviation. We can just set the standard deviation to be a little bit higher than we think. But I do think that we should look into how we can um, accurately, like consistently measure that with like test cases and stuff. And then the angular one is the same thing. So 0.06 radians is 3 degrees. So they believe that their vision is within 3 degrees of correctness. I don't believe that. Usually we throw out the the angle of the the limelight because pigeon like our external IMU is accurate enough that we don't need to rely on the limelight to update our heading. Uh, so we usually just increase this to a really exorbitant number. Um, this, I guess, what they can do is based on your camera. Say we had like a Limelight 4 and a Limelight 3. A Limelight 4 is probably going to be better, so we can weight the Limelight 3 a little bit lower. Um, so that's interesting to know, but we probably aren't going to use that since we have two of the same camera. For Megatag 2 observation, so the Megatag 2 works by taking in your robot's um, calculated gyro or its angle, and then based on that, it's able to kind of eliminate a lot of the ambiguity from the code or from its calculations. This is just because of the math that they use is different. As they're saying here, the Megatag 1 has to calculate everything on its own. Having the angle is really helpful because now you don't have to do the full solve. You already know three of the there's if you're thinking in 3D, right? You've got XYZ, and then if you ever and then for angles you've got pitch, roll, and yaw. So that's rotation along those three axes. You already have 3 out of the 6, so it's just getting those distances. And so because of that, this might seem counterintuitive, but we're multiplying these standard deviations by a smaller amount, so we're saying that it's twice as accurate as Megatag 1. But because we're using the gyro, we don't want to be updating or actually there's no rotation data available because we're already taking the rotation from our gyro. And so because of that, this just means that we don't trust our what the we just this just means that we don't trust our thing at all. Um so hopefully this looks I was looking through some of this. Don't worry about photon vision and photon vision sim. We are not using we are not using that. Um yeah, they're really smart. I don't know what any of this means, but hey, pose observation Megatag 1 and pose observation Megatag 2. So that's kind of and so basically how this works is they up here we take in the add vision measurements and then it periodically just adds the vision measurement to the drive. And then I guess I should talk about that. So I can send a link to the class for more details in the group chat. But basically, the Advantage Skip Swerve comes with a swerve drive pose estimator, which is actually WPILib has that. But basically, what it does is you combine. So, okay, so to set the scene, we have two kind of areas, right? We have. Let me delete this. You have two kind of areas, right? You have Odo. Oh my days. You have Odo, and then you have Vision. Um, so odometry, right? It's accurate. It's very accurate because it measures the motor encoders directly. But it has slip. It has, and that's our main. It has R relative, so it's relative to the robot. Vision, on the other hand, is less accurate. It has no slip, and it's absolute. So, because of that, we want to combine the best of both worlds. And so that's what a swerve drive pose estimator does. What it does is it takes in your odometry and then it uses that as a baseline. So every so like the first time you start up the robot, your limelights are facing away, for example, any of the tags, it's going to be using your odometry and the um the difference from one position to the last to update the odometry. But as so that's the robot relative, right? So everything's relative for odometry. It checks the deltas, it checks the difference, the change, there we go. The change in odometry in the wheel positions over time. You can see that here with the last module positions, like that's kind of what it does. But then anytime vision gets an update, because it's absolute, it'll add a vision measurement, which is what we saw here. It'll add a vision measurement with with the with the vision pose it thinks the timestamp because of latency. So there's camera, I don't know if I explained it earlier, but there's camera latency and then there's getting to the RoboRio latency. And so this takes into account both of that. And then this is our standard deviations. And so basically every cycle it'll this absolute position which is less accurate gets pushed to the S swerve drive pose. So this gets pushed to absolute, and then the robot relative odometry kind of updates it whenever vision's gone. This is always on. This is always on. This is sometimes not available. So whenever this is not available, then odometry takes over, and then those deltas start feeding into the pose. And so that way, with well-tuned uh, standard deviations for odometry and vision, we can get really accurate pose estimation, and we don't have to worry about like being off. So, for example, I know a lot of y'all. I'm just giving an example now. A lot of y'all who are working on the 10340 robot noticed that every time it would come up a little bit short, and so you'd have to change the pose in Path Planner to be like halfway through the intake station. With vision pose estimation, you don't have to do that anymore because wheel slippage and like running into the thing would, even though the robot thinks it's still moving, the vision comes in and says, nope, you have not moved an inch. And so because of that, it kind of overrides, in heavy air quotes, at a simplified version, it overrides the module's deltas. And then that way your robot goes to the same position and you don't have to do none of that weird messing about in Path Planner. It just goes where you want it to. And so that's why we're doing pose estimation. That's why we want to learn vision. That's why we want to learn Limelight. And that's why we're using Advantage Scope and why we're using Advantage Kit, because we want to monitor a lot of that stuff and we want to make sure that what we think is good is actually good and it's not just something we made up in our head. So that was kind of my rundown, a lot of yap about Limelight and all of that. I hope that you found it useful, and salam.